Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0110, refers to an issue with the intake air temperature, IAT, sensor 1 being out of the acceptable range. The IAT sensor's primary function is to measure the temperature of the incoming air entering the engine, which is crucial for the Engine Control Module, ECM, to optimize engine performance and emissions. If the IAT sensor reading is inaccurate or experiences a fault, it can significantly affect the air-fuel mixture, leading to improper combustion and potential damage to the engine. It is vital to diagnose and resolve this code promptly to maintain the optimal efficiency of the vehicle. In the Honda Civic models from 2016 to 2021, this sensor is typically located near the mass airflow (MAF) sensor and can be accessed through the engine bay. Accurate diagnostics are essential, as these codes can lead to performance issues, so a thorough understanding of the vehicle's systems is necessary. The IAT sensor plays a crucial role within the engine management system. Its primary function is to monitor the inlet air temperature that enters the engine, which directly influences the fuel-to-air mixture for optimal combustion. Located near the mass airflow MAF sensor, it is critical in delivering accurate temperature readings to the Engine Control Module, ECM. A proper air-fuel mixture ensures better engine performance and efficiency, and reduces harmful emissions. In modern vehicles, including the Honda Civic, electronic sensors like the IAT provide real-time data that the ECM uses to make adjustments instantly. Therefore, any malfunctions may compromise fuel efficiency and emissions control, and may lead to more severe engine issues if not addressed in time. Several factors can lead to triggering the DTC P0110. Poor connections or loose terminals at critical components can interrupt the signal to the engine control unit, leading to erroneous readings. The IAT sensor itself may also malfunction due to excessive heat, contamination, or wear, impacting the accuracy of its readings significantly. Moreover, faults within the Powertrain Control Module, PCM, can also lead to misleading data about the air temperature, as signals processed from various sensors may become unreliable. Identifying the exact cause is essential, as it instructs the technician on whether cleaning terminals, replacing components, or reprogramming the PCM may be necessary. Neglecting these issues can compound problems and lead to more significant engine performance issues. The symptoms associated with DTC P0110 can manifest in various observable ways. One of the primary indicators is that the vehicle may start experiencing engine performance issues, such as poor acceleration or rough idling due to incorrect air-fuel mixture calculations. Additionally, heightened emissions may occur because of inefficient combustion processes triggered by faulty temperature readings. Another telltale symptom is the illumination of the check engine light on the dashboard, a clear indication that the engine management system has detected a fault. Drivers should take these symptoms seriously, as they not only affect driving comfort, but can also lead to higher repair costs and environmental repercussions if emissions regulations are violated. Prompt diagnosis and repair can prevent further complications. The first step in troubleshooting DTC P0110 involves performing a visual inspection of the connectors associated with the MAF sensor and IAT sensor 1, as well as the engine coolant temperature ECT sensors. This step may seem simplistic, but many issues can be attributed to poor connections or loose terminals. Inspect these locations carefully for any discoloration, corrosion, or physical damage. Ensuring a solid, clean connection is essential, since compromised terminals can lead to inaccurate signals sent to the ECM. which may trigger the DTC codes. If the connectors and terminals are found to be in good condition, the diagnostic can proceed to the next step, allowing further examination of component performance. In this step, the technician will conduct a performance check of the IAT sensor under low temperature conditions. To begin, disconnect the 5P connector from the MAF sensor and IAT sensor before removing the sensor itself for cooling to ambient temperature. Once it is cooled, note the ambient temperature as a baseline. Reconnecting the sensor without installing it allows for a real-time check of the IAT reading using the HDS Honda Diagnostic System. Comparing the IAT sensor's measured temperature to the noted ambient temperature is crucial. If it deviates by 5.4 degrees Fahrenheit, 3 degrees Celsius or more, a faulty sensor necessitates replacement. This step helps confirm whether the sensor is delivering accurate data to the ECM, establishing whether it is a contributing factor to the DTC. The third step focuses on a high-temperature performance check of the IAT sensor. This procedure starts with turning the vehicle's ignition to off mode and disconnecting the MAF sensor and IAT sensor 1's 5P connector. Using a heat gun, apply hot air to the sensor for a few seconds, ensuring not to exceed the time limit to prevent sensor damage. After reconnecting the sensor, check the output values using the HDS once more. Monitor if the IAT sensor changes by 76 degrees Fahrenheit, 42 degrees Celsius or more as the heat is applied. If it does not, this indicates a malfunctioning sensor, requiring a replacement. If the sensor responds correctly, it may instead suggest intermittent issues, warranting another check of connections for faults. After completing the necessary repairs and replacements based on previous diagnostic steps, it is crucial to perform a final verification to ensure that the issues have been resolved. Start with a test drive to allow the engine to operate under normal conditions and monitor its responsiveness. During the drive, keep an eye on the check engine light. Its absence will confirm that the DTC has cleared successfully. Additionally, evaluating the engine's performance during various driving conditions will ascertain that the IAT sensor is functioning correctly. If the engine performs reliably without triggering any error codes, that would validate the effectiveness of the repairs made previously. This step ensures that both the technician and the vehicle owner can be confident in the integrity of the repairs conducted. Preventive maintenance is vital for ensuring the longevity and optimal functioning of the IAT sensor and related systems. Regular inspections of the sensors and their associated connections can proactively identify signs of wear, corrosion, or damage before they escalate into significant issues. Keeping connections clean is imperative to foster proper electrical conductivity, thus ensuring accurate data transmission to the ECM. Furthermore, maintaining an uncluttered engine bay free from debris not only protects sensors, but minimizes the risk of overheating and potential damage caused by accumulation around critical components. Consistent monitoring and care can greatly enhance performance and reliability, reducing the chances of encountering DTCs like P0110 in the future. In conclusion, the IAT sensor is integral to ensuring optimal engine performance and efficiency in the Honda Civic from 2016 to 2021. Understanding its role in measuring incoming air temperature highlights the importance of accurate data for the engine management system. Troubleshooting codes like P0110 requires a methodical approach to identify whether the issue lies within the sensor or its connections. The steps outlined, from visual checks to performance assessments, are designed to ensure a comprehensive diagnosis. Additionally, regular preventive maintenance plays a critical role in avoiding malfunctions and extending sensor lifespan. By adopting these practices, vehicle owners can ensure smoother operation and enhance the longevity of their Honda Civics. Please like and subscribe to the channel. See you next time.